So we have one more change that we can make to our trig graphs, and it's called phase angles. So what we've done so far is we've looked at changing the amplitude. So we've got an amplitude of A. We know what the sine graph looks like, and we know that that's going to be B reps, 360 degrees. And that plus C, we know that it's going to be moved up by C. So we can change how far up and down it goes. We can change what it looks like. We can change the number of times it's going to repeat itself, or we can move it up and down. This last bit, if it's in the bracket, it's called a phase angle, and it moves it left and right. Now, when we were moving it up and down, it was almost a bit of common sense. If it's plus, we're going to move it up, and if it's minus, we're going to move it down the way. If it's the phase angle, it goes the opposite way to kind of your common sense approach. We normally think that if it's going to be a plus, it would move in the positive x direction. So normally our axes are like this and y. And we think that if it's going to be a positive, well, that's the positive direction, so we think it moves that way. But it's actually going to go the opposite way you think. So if it's minus d, now we normally think that minus d would go this way, but actually, if it's a negative, it's going to go to the right-hand side. So this minus d is a move to the right by d. And it's always the opposite way. So let's have a look at the other type. So we've got an amplitude of A. We have a cos graph, which looks like that. We have B reps in 360 degrees plus D. So this is going to be a move to the left by D, and this will be moved down by C. Now you won't get all of these at the same time. So there's 1, 2, 3, 4 different things there. Okay, you won't get all of them at the same time. You'll maybe get 2, maximum 3. Okay, but more often than not, it's just 2 things happening. So let's look at sketching them. So again, I've kind of taken that principle of having 2 here. So I've got an amplitude of 5. I know that my sine graph looks like this. X minus 30. Now I normally think of minus going to the left. I remember that it's going to go the opposite way, so it's going to be a move to the right by 30. Now, when you're drawing this, it becomes slightly trickier. You still want to draw it between 0 and 360. Put your amplitude in first, so 5 and minus 5, because it's not being shifted up or down, so I can put 5 and minus 5 in. Now, it's a sine graph, and I'm moving it to the right by 30. So instead of starting here at 0, I'm going to start here at 30. And what I would always do is I would always draw a full sine graph. Okay? Now, if it's starting at 30, it must be finishing at 390. So we can take a little bit off. And that, roughly, will be 360. It doesn't need to be exact. Okay? You can have this in if you want, and you can keep it going to there, but you need to clearly show that you know at 360, it won't be back at that line. Okay? You need to make that clear. So normally I would add it in and then rub out a little bit. You need to show where it's crossing in the middle. So normally that's at 180, but everything's been moved 30 to the right. So that is now 210. And you need to put this bit in at the front. Now, this is only 30 degrees, so it's not going to go far, but if you continue that graph, it will do something like that. Now, it's not perfect, it probably will be a bit straighter, but again, you need to clearly show that it won't have reached minus 5 yet. Okay, it doesn't matter how far down that line you go, you just need to show it doesn't reach minus 5, okay, because it takes 90 degrees for it to go from 0 to minus 5. And that's it. Now, I'm going to give one for you to try. So yours is on the right-hand side. If you press pause, take as long as you need to try this, and then press play to see how you get on. So in your case, we have an amplitude of 3. We have a cos graph, which is going to look like this, and plus, so this is going to be moved to the left by 45 degrees. Now, this one's starting over here. Okay, so it's been moved to the left by 45. Now, the easiest way to do this is essentially what we're going to have to do is we're starting normally our graph would do this, but the entire thing, and unfortunately I can do this, is going to be shifted to the left. Okay? Now, you need to remember what your key points are. So you need to remember in the middle here is 180, and here is 90. Now, if that's 90, it's not, when I'm moving it, I'm not going to be starting from 0, because that would be a 90 shift to the left. So I need to show that I'm not starting at 3, but again, I'm not starting at 0. And you need to make that clear when you're drawing this. So let's put my amplitude in. Now I know shift to left by 45, so I'm starting somewhere in the middle, and I'm going to go down and back up. And there's my 1 rep. Now, you need to remember, we've moved to the left. You want 0 to 360. Okay, this has been moved to the left here. So this is 315 at the moment. So you need to show it clearly coming back down. Okay, again, it doesn't matter how far down, but you need to show that that technically would have kept going, because this is no longer 360. This is now 315 because it's 45 degrees to the left. This is normally, let's start with this one. So this is normally 90, so that's 45 now because it's been moved to the left by 45. This is normally 180. Move it to the left by 45 is going to be 135. This is normally 270. Move it to the left by 45 will give me 225. Okay, normally if you're going to be putting on it's these bits where it crosses. Okay, you can add extra bits if you want, but as long as you're including where it's crossing the line, and then obviously 360 at the end there. And that's the graph y equals 3 cos of x plus 45. These are the trickiest ones, moving it left or right, so it's a good idea to keep practicing these. Okay.